This is Geometry 3.4, problem number 1. We're looking at this proof, and we are given that BD bisects angle CDA, and CD is equal to DA. So the first thing I'm going to do before I start going through the formal proof over here is to mark up my diagram. In CD and DA, we have CD and DA, so I know those two are equal. And it says BD bisects CDA, which tells me that these two angles here are each going to be half of the total. And if they're each half of the total, they're going to be equal to each other. So bisecting means that it cuts it in half. So now I have a side and a side that are equal, and an angle that are equal. And because for my triangle congruence, I can do angle, angle, side, which would mean I'd have to prove somehow that these two angles up here are equal. Or I could do side, angle, side, and that would be another way to prove congruence. I'm thinking that since I have this shared side, this side's going to be equal to itself. And that's going to be by the reflexive property. So before I even write anything down, I'm already starting to see how I'm going to do this. I'm setting my roadmap for how I'm going to solve this proof. And I see that I have two sides given to me directly. I have two angles that I can infer from this bisection. And then I have this shared side that is equal to itself by the reflexive property. So to solve it, first thing we do is we take our given and we write it down. BD bisects CDA, and CD is equal to DA. Next thing I'm going to do is take my two angles here, and I'm going to say they are equal to each other. I have angle CDB, so 2 here. Angle CDB is equal to the angle on the other side, ADB. And the reason I can do that is by the definition of an angle bisector. So I'll throw that in here. So I have my definition of my bisector as my reason. Next thing I'm going to do is I'm going to establish my third part here. This side BD is going to be equal to itself. And say that BD is equal to BD. And that is done by the reflexive property. And that's a handy property because whenever you have shared sides, it's going to get you those two equal parts. And then finally, because I have all my pieces now, I'm going to be able to say that the two triangles are in fact congruent by side, angle, side. So I'll even start with my reason. It's side, angle, side. And the two triangles I have proven congruent, I have to go in the right order. So I'm going to start with D. You could start with any angle, but I'm going to start with D. And I'm going to go D, B, A. D, B, A is equal to, and I'm going to have to start on the same thing over here, D, B, C. D, B, C. Now it doesn't matter which ones you choose as long as the corresponding ones line up. And because it is two different triangles, I'm going to throw the little triangle symbol in front right here. And here I have my proof. This is where I got to. Now, looking at the way it's written here, it says BCD is congruent to BAD. The corresponding parts are the same, so I could have written it exactly as it is here, and that probably been the preferred way to go.